Greetings, everyone. My name is Dr. Chellatore Sharma. I'm a professor of data science at UNT and also the director of data visualization in Extreme Reality Lab. And today I'll be presenting the paper, which is titled Time Series Analysis for Detecting Anomalous Behavior Using Mobile Devices. So let's proceed with the paper. These are the table of content. This work kind of introduces a mobile application that leverages time series analysis and anomaly detection techniques to identify anomalous behavior and conduct comprehensive analysis using heterogeneous data collected from parking lot data. By utilizing heterogeneous data and providing comprehensive insights into parking behavior, the application empowers decision makers to optimize resource allocation, predict future demands, and detect anomalous parking behaviors. So I'll be talking about the background, and then I'll talk about smart city and parking, and then about our application, about time series analysis and anomaly detection. And then I'll be giving the demo and conclusions. So let's start with the background. Understanding anomalous behavior and spatial changes in an urban parking area can enhance decision-making and situational awareness. For sustainable urban parking management, decision-making kind of relies on data that comes in overwhelming velocity and volume that one cannot comprehend without some layer of analysis and visualization. So detecting anomalous behavior in real time for an urban area from large data is a challenging problem. Efficient parking management in urban areas is crucial for optimizing space utilization, improving traffic flow, and enhancing the overall urban experience. However, this objective is often challenged by anomalous behavior that occurs in parking lots, such as unauthorized parking, violations of parking regulations, and irregular occupancy patterns. So to address this issue, this paper introduces a mobile application that leverages time series analysis and anomaly detection techniques to identify the anomalous behavior and conduct a comprehensive analysis using heterogeneous data collected from parking lots. So urban areas face significant challenges in managing parking spaces effectively, which leads to congestion, inefficient resource allocation, and unauthorized or abnormal parking behavior. So to address this, there's a need to understand the parking pattern and the ability to detect anomalous behavior in real time. So this research leverages data analysis and visualization techniques to enhance decision-making and situational awareness in urban parking management. So this work presents a mobile application that performs time series analysis and anomaly detection or parking lot data for decision making. The mobile application allows users to add pins in the parking lot and analyze the pin data over a period of time. Our approach uses parking pins to identify each vehicle and then collect specific data such as temporal variables like latitude, longitude, time, date, and text information, which could be the license plate, as well as images or video shots at that particular location. So users have the option of placing pins at the location where the car is parked, and the information collected can be used for time series analysis down the line. So by examining the data pattern, we may quickly identify vehicles parked in restricted spaces but without authorization, and parked vehicles in disabled spaces but owned by regular users. So this time series analysis enables the extraction of meaningful insights, making it useful in the identification of recurring patterns in parking lot occupancy over the period of time. This information aids in predicting future demands, enabling parking administrators to allocate resources efficiently during peak hours and optimize space usage. It can be used in detecting irregularities in parking patterns, aiding in the prompt identification of unauthorized or abnormal parking and parking violations. So this figure that we see over here, the image kind of shows the view of the collected data through the use of geolocation pins. Each pin, you can store multiple variables inside it. It's like a tree structure. You can have text, image, video, latitude, longitude, date, time, and all those variables are part of it for each pin. And you could put as many pins as you want in the data input collection, and then that's the data that is used down the line for doing time series analysis on the different variables. So the mobile application that we have developed consists of two key modules: information gathering module and time series analysis module. So out here, those images kind of shows the image can be uploaded from the device using the pick from the device button, or it can be captured through the device using the camera button. So anomaly detection technique can identify abnormal and suspicious parking behavior in real time. This includes detecting unauthorized parking violations or vehicles exceeding the allowed parking duration. So by promptly identifying such anomalies, the appropriate actions can be taken, such as issuing warnings or fines and ensuring compliance and improving overall parking management efficiency. Right, so as we can see in the figure, it collects various data associated with each pin, such as time, date, longitude, latitude, plate information, as well as image, text, and video. So the module serves as a primary data collection mechanism for the application. Next. So the information gathering module, it gathers parking lot information through its information gathering module. So it includes user added pins. So users can add pins on the mobile application to mark specific location within the parking lot. So these pins serve as a reference for data collection. The number two, we have data collection. When a user adds a pin at a location, the application collects various data associated with that pin. This includes temporal variables such as latitude, longitude, time, date, and provides information about when the data was recorded. Right. The third one is image and video capture. Users have the option of capturing images as well as videos at that particular location, and it gets tagged with that pin. And then the last one is integration with the data sources. So the mobile application can integrate with different data sources to gather parking lot information. For example, it can connect to existing parking management systems or databases to retrieve relevant data such as occupancy status, parking restrictions, and reservation information. Next, we'll take a look at information gathering module. So this can bring several benefits to urban parking management. Number one is, of course, predicting parking demand. So time series analysis can identify patterns and trends in the parking occupancy over the period of time. So by analyzing historical parking data, the application can forecast future parking demands during specific periods, such as peak hours or even days. Second is resource allocation. So time series analysis allows decision makers to understand the utilization of parking space at different times, days, or seasons. By identifying high and low occupancy patterns, parking resources can be efficiently allocated. Then the next one is anomaly detection, which is a technique that can identify abnormal and suspicious parking behavior in real time. Right, as we mentioned earlier, it can detect unauthorized parking or parking violations. Right. Next one is optimization of space usage. So time series analysis helps in understanding parking patterns and usage trends throughout the day. And the last one is, of course, looking into decision support. The analysis of time series data and anomalies provide decision makers with valuable insights for effective decision making. So by visualizing the data and presenting meaningful patterns and any outliers if they are. So this image is kind of showing the time series analysis module, which analyzes the collected data over the period of time. You could set the minimum and maximum time and then look at the analyzed data. It enables administrators to understand the occupancy patterns and trends in the parking lot over the period of time for predicting future parking demands and optimizing the allocation of parking resources. So the data collection, the mobile application collects various data variables. So number one is the temporal variables. Temporal variables include the date and time of data collection, allowing for analysis of parking patterns over different periods. Additionally, latitude and longitude data provide spatial context to understand the distribution of parking behavior across the parking lot. Second one is license plate information, which is collected to identify individual vehicles. This data helps track parking duration, detect unauthorized or abnormal parking, and link the collected data to specific vehicles. And number three is, of course, image and videos. Users have the option to capture images and videos using the mobile devices, as we shown in the previous figure. So this mobile application was developed for both Android and iOS system. The application layer was built using .NET MAUI platform, multi-platform app UI, a framework that enables the development of cross-platform mobile application using C# and XAML. It also integrates Google Map API within the system. So next thing is looking into the key components of the system architecture. So we have data collection layer. So data collection layer is responsible for gathering data from various sources. It includes modules or components that interact with different data providers such as parking or occupancy sensors, smart meters, and any external APIs. Then we have data integration layer, which is responsible for consolidating and harmonizing the heterogeneous data collected from different sources. It includes data preprocessing module that transforms and standardize the data to ensure compatibility and consistency. Then we have data storage layer, analytics and processing layer, visualization layer, integration and external systems, scalability, real-time processing, data governance, model training, API, and then of course at the end, data privacy and compliance as well. So here's how it can address different parking violations. So unauthorized parking in restricted areas, occupying disabled parking spaces without authorization, or time-limited parking violations, or parking in reserved or a vehicle parked at a wrong space. So as we mentioned earlier, anomaly detection functionality of the application plays a crucial role in identifying irregularities and abnormal parking behavior. These are a couple of demos. I'll probably try to play all of them at the same time. This is looking at the modules, the data input module and the time series analysis module. So as you can see in the left menu, you can save the user ID, you can enter description, and you can add all these things and tag the location as a pin. So in a day, you can go and have multiple pins associated with that location. And in a day, in a week, in a month, then if you have the data captured in the input module, then of course you can do the time series analysis and see what kind of cars were parked over the period of time. So this is exactly what it is showing. So in the interest of time, I'll move forward. This is another phase 2 of the work that we had done, and this was more taken it into Quest 3, and using Unity, we expanded on the module to have it in mobile as well as on Quest 3. So I guess in the interest of time, I'll move forward. So in conclusion, the development of the mobile application incorporates time series analysis and anomaly detection for urban parking management, and it offers significant benefits for decision-making and situational awareness. Information gathering module allows users to add pins to parking lots, capturing essential data such as location, time data, license plate information, images, videos, text information, and so on. And time series analysis module analyzes the collected data, enabling the identification of recurring patterns in parking lot occupancy and the detection of anomalies or irregularities. These are a couple of references and acknowledgement. Thank you very much, and that's the end of the presentation.